So the SAT problem you see here is taken from Practice Test 6, Math Module 2 of the Practice SAT tests available through the College Board's website. And this is the updated set of practice tests that correspond to the new digital SAT. And this particular problem is pretty tricky. So let's try to get into it here. So it says in the XY plane, we've got a circle with center C, and the coordinates of that center C are h, k. They tell us points A and B lie on the circle, and they actually give us the coordinates of point A, but they don't give us the coordinates of point A as numerical values. They give us the coordinates of point A dependent on H and K. It also tells us that angle ACB, now think about this, A and B are on the circle, C is the center of the circle, so C is where the angle is actually formed, where the vertex of that angle lies. What we're asked to find is the length of line segment AB. Now, when I first read this, I started to try to develop the equation of the circle, and I was trying to do some work like that, and it didn't really get me anywhere. So I thought, let me backtrack. Let me see if I just draw a diagram. Is that going to be useful? So the way that my diagram started was simply with point C, the center of the circle. I know the coordinates of the center of the circle, h, k. Now what you don't see anywhere within my diagram here is you don't see a coordinate plane. And the reason for that is I don't really know what the specific coordinates of h and k are. So I don't really know if this center is in the first, second, third, or fourth quadrants. But we'll try to talk about why that doesn't matter over the course of the next few minutes. So I started with point C, center of the circle, h, k. I drew my circle, didn't know the radius of the circle, so I didn't really know what size to draw it, so I just kind of drew a circle that I could do a little bit of diagramming within. And then what I recognized is that the coordinates of point A are given to me. Keep in mind, h is the x-coordinate of the center. The x-coordinate of point A is 1 above that. So what I did when I plotted point A, so all I had on my diagram at first was just the center and the circle. To plot point A, I went a little bit to the right, The x-coordinate between the center and point A has increased by 1. And then the y-coordinate for the center is k, but then for point A is k plus square root of 102. Now square root of 100 is 10, so square root of 102 is just ever so slightly above 10. So what I did when I plotted point A is I went over 1 unit, and then I went up approximately 10 units, and then I plotted point A on the circle. I listed the coordinates of point A right beside it. Now point B, I don't necessarily know anything about point B other than the fact that it lies on the circle. But I also know that if I draw an angle starting at point A, connecting to point C, and then ending at point B, I know I get a right angle. So I could have that angle, that right angle, looking like I have it drawn in my circle here, or I could have it looking like working out this direction. No matter which side of the center, left of center or right of center, I decide to place point B, I'm going to end up with a triangle that is guaranteed to be a 45, 45, 90 triangle and an isosceles triangle. How do I know that? I know this is a right angle. I know that B is on the circle. So the distance from the center to point B and the distance from the center to point A is going to be the same. What we're really trying to find here is we're really trying to find the length of line segment AB, this top part of the circle, of the triangle rather. So what this ultimately becomes, it's a problem that involves circles, and I overthought this myself initially as well. I was trying to find the equation, trying to do some work like that. When I broke it down, it really ended up being a triangle problem. So what I wanted to figure out is what the radius of the circle was, These measures are going to be the same on this triangle, this right triangle. So I used the distance formula. So here's my distance formula. I treated point A like point 2. So x2 was h plus 1, y2 was k plus 1 square root of 102. And then I treated point C like point 1. So x-coordinate of point A minus x-coordinate of point C, x-coordinate of point A y-coordinate of point A minus y-coordinate of point C. Now what you'll notice is that this h and this h are going to cancel with each other. One's positive, one's negative. This k and this k are going to cancel with each other. One's positive, one's negative. What that leaves us with is just 1 squared plus square root of 102 squared. Well, if I square the square root of 102, I get 102. 1 plus 102 is 103, and that's going to have a square root applied to it. So what that tells me is that this measure from center of the circle to point A is square root of 103 units. Because BC is also a radius of the circle, I know that has the same measure. So if we go to a new screen here, we'll finish this up. So I kind of took the circle away. I know I have an isosceles right triangle. I know that both of the legs of that right triangle measure square root of 103. So what this boiled down to was a Pythagorean theorem problem. So I'm trying to find the measure of this hypotenuse. So the hypotenuse squared has to be equal to the leg squared plus the measure of the other leg squared. Squaring the square root of 103 gives me 103. 103 plus 103 gives me 206. Undo that exponent of 2 on the length of segment AB, and that tells us that the length of segment AB is square root of 206, and that is option A.